Within just 2 days of observations, Atlas radiated with intensity. Its brightness exceeded cometary models' forecasts by a wide margin. The modest icy traveler transformed into a stunning display, 6 times brighter than anticipated. A halo of gas and dust erupted outward, forming a vast green cloud. To astronomers, this wasn't just an increase in brightness, it was a dramatic transformation. The object shifted from ghostly faint to a brilliant beacon lighting up observatories around the world. This expansion resulted in a coma of massive proportions that surpassed imagination. At its zenith, it reached nearly half the diameter of our Sun. The eruption was anything but subtle, it was a cosmic announcement, as if Atlas had activated a signal that demanded attention. Telescopes rushed to track its movement, but time was limited. The object was rapidly approaching the inner solar system, nearing Mars at a breathtaking pace. That speed was astonishing. Atlas traveled at nearly 70 kilometers per second, twice the speed of Mercury, the fastest planet orbiting the Sun. To illustrate, a trip from Earth to the Moon, which took Apollo astronauts 3 days, would take Atlas merely a little over an hour. Remarkably, this was not even its maximum speed. As it neared the Sun, it would accelerate further, hitting around 68 kilometers per second by late October. Only the Parker Solar Probe, the fastest machine humans have ever built, could match such speed, requiring years of gravity assists to achieve it. Atlas, however, effortlessly gained this speed, driven solely by the Sun's gravitational pull and its trajectory through interstellar space. The statistics were staggering, but so was its luminosity. Stars that can be seen with the naked eye fade at around magnitude 6. In its outburst, Atlas surged to magnitude 12. While that might seem minor, astronomical magnitudes are logarithmic, indicating exponential changes. Moving from 16 to 12 isn't a simple transition, it's a dramatic increase in brightness, nearly 40-fold. Yet even with this brightness, the comet remained invisible to the unaided eye. Only experienced astronomers using mid-sized telescopes in pristine dark skies could catch sight of it, if they were lucky enough, only as a faint blur. Behind that blurry image lay a scale far grander than what the human eye could perceive. The coma extended hundreds of thousands of kilometers across, dwarfing planets, scattering light over a vast expanse that resembled an entire world evaporating into mist. Its orbit only added more intrigue. Atlas wasn't tethered to the Sun. Its trajectory was hyperbolic, merely passing through our solar neighborhood before disappearing into oblivion. Unlike Halley's Comet or other returning visitors, Atlas stood out. It was an anomaly, a wanderer from another system, likely traveling for millions, possibly billions, of years before fate brought it close to our Sun. This transient appearance made observations urgent. Once it swung around the Sun, it would never return. By October 21st, its angle concerning the Sun would narrow so much that even the most powerful ground-based telescopes would be blinded by glare. During weeks leading up to its closest approach, Atlas would be invisible from Earth. Imagine the frustration of knowing that an extraordinary event was unfolding just out of reach, forcing observers to look away. The urgency was tangible. The astronomical community responded like clockwork, exhibiting the swiftness akin to an emergency procedure. Amateur astronomers reported anomalies almost immediately. Databases filled with new findings. Major observatories rearranged their schedules to maximize every possible observation before the comet vanished into solar radiance. The Hubble Space Telescope shifted its focus, obtaining ultraviolet images at the last possible instant. The James Webb Space Telescope, booked for years ahead, carved out precious time for mid-infrared spectroscopy. Ground-based giants in Chile, Hawaii, and Spain joined in the quest, striving to capture details before sunlight obscured the display. Even wide survey missions like NASA's SphereX adapted their schedules to gather snapshots of this peculiar intruder. To researchers, Atlas represented more than just another interstellar traveler. It was a chemical time capsule, a messenger carrying the frozen elements of another star's birthplace. Its explosive eruption suggested conditions and processes that lay beyond our solar system's limits. Moreover, the violent outburst near the Sun implied that its structure was delicate, volatile, and potentially more intricate than anticipated. For now, the intrigue surrounding Atlas persists. It is more than merely a comet, more than just another icy visitor. It serves as a cosmic reminder of our limited knowledge regarding the galaxy beyond. This traveler from another sun bears chemistry both alien and familiar, urging us to reconsider what awaits in interstellar space. As it slips into the void, it leaves us with an unsettling notion: perhaps our solar system isn't as isolated as it appears. Perhaps the stars deliver visitors more frequently than we realize, messengers traversing through the cosmos, each laden with stories of worlds we have yet to encounter. When astronomers first noticed the strange features of 3I, Atlas, they expected to find answers rooted in familiar cometary science. Instead, what emerged was something that stretched the imagination. The object didn't just form a tail streaming away from the Sun, as physics dictated. It developed an anti-tail, a stream of dust and particles seemingly pointing back toward the Sun. At first, many dismissed it as a mere illusion caused by Earth's vantage point, a geometric trick of perspective. But when weeks of observations from Hubble and ground-based telescopes confirmed its persistence, the mystery deepened. Models suggested that uneven jets blasting from the comet's surface may have hurled massive dust grains into configurations that made the tail appear reversed. Others speculated about plasma interactions, self-organizing fields, even engineered structures, but mainstream astronomers urged restraint. Unusual, yes, but still within the realm of natural physics, at least for now. Even so, 3I, Atlas offered something scientists rarely encounter: a natural laboratory to study the raw materials of another star system. As the comet slipped beyond the reach of Earth's telescopes, the task of observation passed to an unlikely group: spacecraft orbiting Mars. Suddenly, probes designed to map the red planet were redirected toward this alien visitor. NASA's Mars Reconnaissance Orbiter, with its razor-sharp high-rise camera, prepared to image the nucleus. ESA's Mars Express pivoted its wide-field stereo camera to capture the coma. The Trace Gas Orbiter, armed with sensitive spectrometers, stood ready to confirm unusual carbon dioxide levels. Even MAVEN, built to study Mars's upper atmosphere, adjusted its instruments to track ultraviolet emissions and monitor how the solar wind interacted with the expanding cloud of gas. In a matter of weeks, engineers rewrote schedules, patched software, and ran simulations to protect instruments from the sun's glare. Every moment of observing time became precious, divided between planetary science and a once-in-a-lifetime cometary investigation. Together, these orbiters became a synthetic observatory, an unplanned alliance chasing a fleeting mystery. And with the comet approaching its closest distance to the Sun, the stakes only grew higher. What would happen when 3I, Atlas faced the full intensity of solar radiation? Some scientists predicted a spectacular flare, the comet shining brighter than ever before. Others believed the nucleus might fragment, crumbling under heat and gravity, briefly scattering light across space before fading to nothing. Another possibility was complete disintegration, the object dissolving into a cloud of debris and dust, its secrets lost forever. Each scenario carried implications. What survives the journey between stars? How do alien ices behave under a new sun's energy? And, most haunting of all, how many other interstellar travelers drift silently through the galaxy, waiting for a moment of discovery? The coming weeks promised answers. Mars orbiters would return crucial data. Models would be tested, refined, or discarded. And when the comet finally emerged from solar glare in November, humanity would have one final chance to glimpse what remained of 3I, Atlas before it slipped back into eternal night. The urgency was palpable, because interstellar visitors are not just comets, they are time capsules. They carry chemistry from distant stellar nurseries, offering clues about how planets form, how molecules survive the dark between stars, and perhaps even how the seeds of life spread across the galaxy. The strange green glow, the anti-tail, the violent eruptions, all of these are signals from another world, encoded in dust and light. For a brief moment, humanity has the chance to decode them. But time is short. The cosmos does not wait, and soon this messenger will be gone. Whether it fades gently, fragments in chaos, or explodes in one last blaze, it has already changed our understanding. It reminds us that the universe is vaster, stranger, and more dynamic than we often imagine. This story matters not only because of astronomy, but because it reshapes our place in the cosmos. Some travelers pass quietly, others blaze with spectacle, but everyone challenges us to look harder, measure more carefully, and accept that despite centuries of watching the skies, we are only scratching the surface. If this glimpse into the unknown has sparked your curiosity, join us as we continue to explore the mysteries of the universe. Subscribe, turn on notifications, and stay with us as we follow stories like 3I, Atlas and beyond. Because the skies are full of